Thank you everyone for joining us today. Today's webinar, we'll obviously be talking about image classification models, some of the use cases, but also how you can rapidly build them with a declarative approach to ML. So we're excited to share that, and we have a fun holiday-themed demo as well. So jumping right in here, let me turn the slide. My name is Michael Ortega. I lead marketing here at Predibase. I'm joined by our co-founder and chief product officer, Dev Rishi, who's going to be doing the majority of the presenting today in our cool demo. And for those of you who don't know us, we're Predibase. We're the first low-code declarative ML platform that's really designed to help all different level of experience of users on the data team to rapidly build, iterate, and deploy state-of-the-art ML models with just a few lines of code or through a short drag-and-drop interface. And you'll get to see that in action today with Dev's demo, which is going to be exciting. And just a quick reminder before we get started today, just typical webinar logistics. All the lines are muted for everyone who's in attendance, but we do want your questions, so please post them into the chat box on the side there. You should have a side box where you can put your questions, and we'll do a live Q&A at the end. As a reminder, if you're excited about what you see today, please visit predibase.com. You can check out the platform or request access, and of course, we'd love more folks to be part of the growing Ludwig community. So you can go to the Ludwig website as well and join that. Oops. And that's it for the intro. So now I'm going to pass it over to Dev to walk us through the majority of the content today. Dev, take it away.
Awesome. Thank you very much, Michael. And I'm just going to wait for the presentation to get loaded up, which looks like it has now. So as Michael kind of mentioned, I want to walk through, what we talk about when we mean declarative machine learning, which is really, our approach to low-code machine learning that we think really works for users well in practice. And we're going to have a fun demo today. We're going to make it holiday themed, so you'll be able to see exactly how you build low-code machine learning and deep learning models for image classification with a little Christmas twist. Before we kind of dive into that use case, though, I just wanted to set the stage for what it is that we're actually looking to build and why. And I'll just start off briefly kind of with my experience in machine learning and some of the experience for some of the other founders on the team as well. So, I like to say I'm not an expert in machine learning. I probably know enough to be dangerous. But I had an opportunity to see it in operations kind of across a few different teams. I spent time as a PM on Google research, thinking about how to put models into production from there. Vertex AI, which is Google Cloud AI platform, and also Kaggle, which is a machine learning community of about 8 million users who collaborate with each other, compete on ML competitions, share data sets, code, and more. And, I think one of the things that I've particularly been excited about over seeing machine learning kind of over the last decade is the massive growth that enterprises have in potential, especially when it comes to unstructured data, where ML and deep learning in particular can be really helpful. So Gartner estimates that about, unstructured data represents 80 to 90% of all new enterprise data. It's growing a lot faster than tabular data, than your structured data. And I think the really kind of interesting thing about this statistic is that, very few companies can effectively leverage that type of unstructured data because it requires deep investments in AI. So this is something that I think a lot of folks are probably, intimately familiar with. Lots of companies invest in AI and machine learning, but very few companies really generate what I think we'd consider strong ROI from those. So here you probably see some of the conventional names you might expect. Netflix with content recommendations, Meta with investments that they might be doing in VR, moderation, and other practices, Tesla with computer vision for self-driving cars and others. I think those are the types of companies that we think about that are really kind of using and effectively leveraging machine learning at scale. But for most of the other organizations that we talk to, especially when it comes to leveraging unstructured data, things like text, images, audio, and others, we see a lot of them really kind of fail to be able to make meaningful strides in what they would want to do in order to deliver bottom line impact. And so at Predibase, what we're really kind of passionate about is taking our experiences working at some of these companies and seeing how machine learning got done internally and making it accessible for a lot more organizations across the fold. And I think, one really nice way to be able to paint this picture is just thinking about my co-founder Piero's experience at Uber. And while Piero was at Uber, I would say he's very much the expert data scientist. And he worked across a number of different use cases to have machine learning deliver value kind of to the bottom line of that organization, including things like automating customer support so that you can better understand, what complaints were coming in and suggest solutions, thinking through fraud detection, especially between driver-rider collusion, and even building recommender systems for things like Uber Eats, where you might be looking at images and previous interaction data to recommend restaurants and dishes to increase usage, since that was a really popular property, especially during COVID. So Pierre had all of these different use cases that he worked on at Uber that were really delivering bottom line impact. But from his perspective as a data scientist, he started off essentially approaching it, I think, like almost everyone approaches machine learning as they start off on projects today. And that's by writing a lot of intensive code. And so, the first project that he worked on, intent classification, was about 1,500 lines of TensorFlow code. Took 5 months to be able to kind of develop and 7 months to deploy. And I think the really frustrating thing is that, in most machine learning projects, this is just the template that you essentially need to work through. Every single kind of project that you start off on, you sort of start off defining your pipelines from scratch. And that means that each marginal use case you might want to work on is going to be something that requires an expert several months to be able to develop, and then likely several months in order to be able to actually deploy. Now, I think this is frustrating for an individual user level or a data scientist because they're sort of reinventing a large part of the wheel each time that they have to work on each subsequent problem. And for organizations, what they're really seeing is that there are very few people that can tackle this problem in the first place. And it takes them several months at least to start to get good solutions into production and delivering meaningful business value. And that, I think, really drags down the ROI that you see for these projects kind of holistically. There's been an attempt to try and simplify this. This is something that I think the machine learning community has identified over the last 5 to 10 years, which is machine learning is too hard. And so there was an attempt to simplify this with automated machine learning. Or AutoML, which is simple and fast, but at the same time limiting. And almost all the customers we talk to today say AutoML is good for prototyping, but never something that they actually use in any serious applications. Because when a task, just gets complicated, like all real-world tasks do, it just breaks down, and they need to switch to manual development to get that flexibility that they would need in order to be able to tackle that. And so what we're interested in is a better option that we call declarative machine learning. And to us, declarative machine learning is what we mean when we say low-code machine learning. It's a level of abstraction that tries to provide the best of both worlds between giving you the flexibility to be able to control any of the different types of the models that you might want to be able to use with the simplicity of AutoML. The goal is that we want to be able to open the door for non-experts to use the power of machine learning, but make sure that the ceiling remains high enough that expert users can also get the control they need to reach the outcomes that they want. And that's really, I think, the key principles around, declarative machine learning is to be able to provide, the kind of continued axes between flexibility and simplicity. And if we kind of look back at those top 10% of companies that I think have been effective at really using machine learning internally so far, they sort of know this. They know that you don't want to be able to develop every machine learning project from scratch. And instead, you want to have a higher level of abstraction that more users can use. And so, a few examples of this is Overton at Apple, which is a closed source system that's developed internally, and it feeds billions of queries to date, especially within Siri. Looper, which is a declarative machine learning system that feeds a lot of machine learning predictions, about 4 million QPS at Meta, also an internal platform. And then finally, we have Ludwig at Uber, which Piero developed as kind of Uber's internal implementation of declarative machine learning system once he got tired of having to develop every kind of successive machine learning project from scratch. And the really nice benefit about Ludwig is that it's open source. So it's something that we can dive really deep into kind of in this conversation. And I can show you a lot more about, how the internals of that system works. And you can try it out for free and just get started with it to try and understand how it might be able to benefit you in kind of your model development journey. Predibase is the company that's then going to bring declarative machine learning to the enterprise. So our goal is to say, many different large tech companies have their internal systems that they are able to develop and maintain. But how do we think about, the vast majority of companies that don't want to develop their own internal declarative machine learning platform? And we want to be able to be kind of that platform for them. Now, if I delve into what does declarative machine learning look like in practice, I'd want to use Ludwig as the example, because it's one, something that we developed on the co-founding team. In particular, Piro was the author, and two, it's open source, so we can actually really get into the internals. Now, some of the principles with Ludwig is it's easy to start. So this is where that simplicity came in from. If you remember that content classification use case that Piro had to develop while he was at Uber, that entire 1,000 lines of TensorFlow code can basically be decomposed now into these 6 lines of configuration. So instead of saying, I need to go ahead and write the code for how my data is pre-processed, my model is built, and my outputs are kind of consumed, you can essentially just say, build me a machine learning pipeline with input as text and output as my category, and then we'll handle all of the rest. So this kind of makes all of machine learning go from months to probably more like minutes, and it's really kind of readable and reproducible for any users. However, we understand that a lot of cases, what this is going to do is give you your starting point. And so really, I think important part about Ludwig is that expert level of control. So as you want to be able to customize your pipelines as much as possible, you can change things like the encoder that you might use, how you want to set the training loop if you regularize or not. And you can really get advanced functionalities as well, like state-of-the-art hyperparameter search out of the box. You'll never have to implement something like async hyperband again, or think about, how do I effectively prune trials that aren't working well. You can sort of use pre-built functionality that you can customize to make sure works the best for your use case. And I think, Ludwig has certainly gotten a little bit of popularity, slight vanity metric slide, but we've been really fortunate to get a lot of contributors from the open source. And we've absolutely valued that a lot. Folks that are developing both things like assets and tutorials of how you can use Ludwig to be able to solve certain types of use cases, as well as making contributions to the kinds of models that we have available as well. If after this, you like kind of what you see and you want to be able to check out Ludwig, please give us a star and let us know what you think in the Ludwig Slack as well. Now, one thing that I want to do is dive a little bit into how Ludwig establishes those machine learning pipelines. This part will get a little in the weeds, but I think it's a very fascinating kind of model architecture. So what Ludwig in that configuration file will do for you is create kind of an entire machine learning pipeline. And it uses a specific type of model architecture to generate that pipeline that's very flexible, and we call encoder, combiner, decoder. What that really means is that you have many different types of data that you can see represented on the left as inputs. So Ludwig can handle things like you might normally expect, like categorical, numerical, and binary features, but also more complex features like sets, vectors, text features, image features, time series, dates, audio, and others. Those then get passed through a series of ML pipelines called encoders. What this allows us to do is be able to use a best-in-class machine learning model to be able to support that particular modality. We pass them through a central machine learning model called a combiner, and then they get decoded into outputs on the other end. What this model architecture really kind of employs is a high degree of flexibility. And I can show you that in the kind of context of the tasks that Ludwig can support. For example, if I wanted to build a text classifier, I essentially have text as an input and category as an output. And I can use the same architecture to be able to build that. If I wanted to build an image captioning system, I have an image as an input and a text as an output. And this is going to build an image captioning model, for example. If I want to do classical regression, I might have my tabular data as inputs and then a numerical output. And if I wanted to do something like really interesting, complex, and multimodal, for example, visual question answering, I might have both text and images as inputs, and then be able to do binary outputs as well. For those of you that were able to join our last webinar, we walked through a multimodal use case where we had text, images, and numerical data. And we were trying to predict whether or not user accounts were bots or humans on Twitter. And all of it was essentially using the same type of model architecture that is really flexible and able to get many different tasks done with the same type of model. And now at Predibase, what we really want to be able to do is bring this type of architecture and declarative machine learning development to the enterprise and help users go from their data to deployment. And the way that we do that is we have this, this core layer of Ludwig as our model builder. So this is the way that you can do declarative machine learning training as kind of like our genesis and starting point. But we've built a lot of functionality around it, starting with data connectors to make it easy to be able to ingest, as well as adding functionality like experiment tracking, management, and iteration, and then a deployment story that supports real-time and batch. So users can build, iterate, and deploy their models on top of fully scalable machine learning infrastructure that really deploys across any cloud platform. So Ludwig is kind of the core part of like how we think about declarative machine learning within Predibase. And we built a lot of functionality so you don't have to worry about the infrastructure, and you get a really nice managed interface for how you can actually start to approach it. And our goal is that this will unlock a lot more possibilities for users across an organization that makes them much more productive, and therefore they see a lot more value kind of delivered as well. Now, the specific thing that I wanted to dive into today was how you can use something like declarative machine learning for tasks in computer vision. And one of the reasons that I wanted to dive into computer vision is, we see a lot of opportunity for people building CV models. And the opportunity exists across industries, in media, where you might do things like tagging, retail, transportation, manufacturing. You might want to look at things like segmentations, building recommender systems that really leverage this kind of rich modality. So there's a lot of opportunity that we see and get requests from customers as well. But building computer vision models is pretty difficult. So building computer vision models, I think really you oftentimes run into three types of challenges. The first challenge is you're starting off essentially immediately with deep learning. And so you need to know a fair amount around either PyTorch, TensorFlow, Keras, one of the deep learning libraries, so that you can even get started in kind of working with this modality. Then the second challenge you will run into is you'll find images have their own kind of special corner cases you need to think about. There's a lot of essentially like specialized knowledge in terms of how you would be able to work with this type of modality in order to be able to even build a model pipeline that trains end to end. And I'll dive into what some of those look like in just a second. And then finally, images present a lot of scaling challenges. Image files in particular tend to be a relatively large modality. So every image, for example, can be pretty expensive to be able to compute on, which means that your infrastructure and the ability to parallelize and distribute the compute becomes a lot more important. And I haven't met very many people that love to be able to spend a lot of their time debugging parallelized compute for distributed machine learning model training, and that becomes like a critical thing for users that are going to try to do this without a more managed platform. But as we said, there's a lot of value that kind of comes out of this. So what I want to be able to kind of walk through today is an example computer vision use case. And so in this example, we're going to imagine we're a streaming company called Webflix. And we want to identify Santa-themed movies to feature during holiday promotions. We want to be able to show people, unfortunately, our catalog isn't tagged with something like this is a Christmas movie or it's not. So what we want to be able to look at is the cover art for that and see, is this something that we think would make sense to be able to show around the holidays? So this is the type of problem, for example, obviously kind of, a fun one for us today. But the type of problem you could imagine people will start to think about as they think about recommender systems or just building basic image classification to start off with. Now, what would be the challenges or a typical computer vision workflow if you're trying to build this model? So in this case, what we're going to do is we're going to train a model to recognize if an image has Santa or not. Now, the first thing that you'll need to do in your image modeling pipeline is you'll have to work on the pre-processing of the data. And this is where I think images have a lot of their kind of own special cases you need to consider. So a few that we've kind of listed out here are that images come in many different formats. And so you'll need to think about how do I collapse those in and think about having a standardize those in some way that I can consume them as inputs into my machine learning model. Images at the same time come in many different sizes. So you might have to resize that image, decide if you want to crop, how you want to pad. You have to think about the number of channels that are in images. So if it's just black and white, there might be 2 channels. If there's colors, it might be 3. If you have black and white and transparent, there's 4. There's a lot that essentially goes that you might have to figure out right at the beginning before you've written a single line of actual machine learning code. But once you've figured out these challenges, then we get to the rocket science of it all, which is writing the machine learning code and the low-level code to be able to actually do this. And I think you can get started by and it should get started by maybe downloading, for example, a rough architecture that you can start to use. But what we often notice is that those architectures work up to a point, but then you'll need to start to implement some of your own advanced functionality on top of that. For example, you might have to figure out, how do I want to normalize my batches so that I actually get good performances? And then, as we were talking about earlier, you'll need to think about how all this model training works well on distributed infrastructure. So how do I parallelize the fact that image files are quite large and have reasonable batch sizes in others for users to be able to use? And so model training itself, I think, is a challenge that will require somewhat expert users. And then finally, I think our strong opinion is that we've rarely seen anyone's first machine learning model be their last. And so you will want to iterate, I think, over time. This is something we've seen in every machine learning project, which is you might start with something like pictures and try to determine whether or not it includes Santa or not. But every image and every kind of data modality we've run into typically has some metadata associated with it as well. Maybe the movie title or the file size, some things that might be potentially predictive about whether or not this particular thing that you're looking at is actually going to be classified in the way that you think it should be. And so as you bring in new and additional types of data, that means you have to go back, edit your preliminary, maybe pre-processing and machine learning model pipelines to be able to incorporate this additional metadata. And that, of course, we see as being a pretty big challenge for a lot of users as well. And as you can probably guess, the hard part at the very end of this is then deployment, which I think we won't even cover all the different types of challenges that we run into here, because I want to make sure we have time for the demo. But the bottom line is, training the model in the first set of these 3 challenges might only be the first half, and then you still need to think about, how do I actually operationalize this? Now, computer vision is going to be made really easy with Predibase and Ludwig, and that's kind of the goal of what I want to be able to show you today. And I think one particular thing I'll do is I could talk you through what some of these configurations could look like and how they would make it a lot easier. But I always believe that it's actually much better to be able to show you, and so I'll just jump directly into the demo. And tell you a little bit about how you could solve this type of use case now using a declarative machine learning platform like Predibase. So if everyone can see my screen, this is essentially the Predibase platform. And you can see that there's really a few key user journeys and a few key functionalities that we have. Users connect data, they train and build their machine learning models, and then they can operationalize those models. And there's a few different ways that they can operationalize those, and I'll come directly to it. There's also this kind of additional piece of the platform that really runs more under the hood, but is configurable by users, called engines. And I'll click and just show you a little bit about what engines are before we dive into the use case. Engines are essentially abstractions on top of compute that make it easier for users to be able to not have to worry about any of the machine learning infra that they'll have to set up. And so you can see there's many different types of engines. You could have CPU engines that might be small, medium, large, GPU engines of the same size as well. And if I click into any one of them, I can kind of see what exactly I get if I'm really curious about the details. So here, this medium GPU engine contains some T4 GPUs and like a high CPU preprocessing nodes. Now, if I don't know what any of that means, that's all totally fine. I usually just consider that this is like a medium-sized GPU engine that might work well for this size of tasks. We've also created 2 additional special classes of engines that is new functionality that we have, which are called training engines and serving engines. And without getting too into the weeds here, the key idea is that if you know exactly the kind of compute that you want to use, you can select it just by creating an engine with that compute. But if you don't know what kind of compute is the best one served for the task, you can select a training engine. And what a training engine will actually do is look at both your model and your data set, and it will right-size the compute directly for that task. So this makes it a lot easier for users to be able to get started kind of on that model development journey. So that's a little bit about engines that's going to be powering us through under the hood. And now let's go ahead and dive into the specifics of the use case. So the use case today we're going to call Santavision. And so the first thing you'll do in Predibase is you'll connect data. We support data connectors to a number of different types of sources. You have your structured, tabular data warehouses, something like a Redshift BigQuery. You also have your object storage like S3 and GCS. Once you've connected data, in this case, I've just uploaded a file with some paths to images in S3. you can kind of see a little bit about the metadata of it. And you can see here, essentially what I have is image paths, a month field, a label that I'm looking at predicting, and then the split for my data set. And let me show you a little bit about what this data set actually looks at. So I'm going to hop over to our query tab. And one of the really kind of clever things about the platform is we have this interface where you can write sort of any SQL query directly into be able to explore your data. So here I'm going to select 10 random examples from the Santavision data set to get a look at what does this data actually look like. And so what you can see here is we have pictures, and we're trying to predict whether or not they're pictures of Santa or not. So here we do have a Santa. Here we have not a Santa, and so the label is false. And similarly, you can kind of see this all the way down. And so, if we think about our Webflix example, maybe some of these are cover arts, and we're trying to build just a classifier to understand, and based on an image, is there actually, Santa or not? We also have these two additional columns, split, which we can actually ignore for now. It's just something that I've added to the data set to make sure we use the same subsets of it for training, validation, and test splits, as well as an additional piece of metadata, which is the month the picture was taken in. And we'll come back to that, towards the end of the demo as well. Now, if I have a data set like this, and you might have many different types of image data sets for what you're trying to do classification that look like this, I want to walk you through how you could actually build your first model for this. So I'll go over to the models tab, and I'll create what we call at Predibase a new model repository. And I'll say this is the Santavision webinar one for demo. And a model repository is essentially an area where we allow users to be able to store and kind of collect and track all of their different model iterations so that they can easily manage them in one place. So once I'll initialize my model repository, I can train my first model. Now, training a first model is really simple. All I'll essentially do is select the connection to where I want that model to be able to come from. So in this case, my data set was the Santavision data set. And I can give that model, a very brief description. So I'll say this is my basic defaults starter model. And, I have a few different selections that I can make, but I think the key thing is Predibase makes a lot of your life easy by making some default suggestions right out of the box. So if you wanted to, for example, train a large number of baseline models, you could hit Explore Suggested Models. But today I just want to build a single model. You'll notice that I also select the engine in this particular task. The engine that I'm going to use usually is my training engine because it'll right-size the compute for me. But in this case, I'll just go ahead and use a GPU engine because it'll be a little faster since I just warmed it up. Then I can choose the model type I want to use between neural networks and gradient boosted trees, which might work a little bit better for tabular data. In this case, I'll just stick with all of the default settings that Predibase gives me. And you'll be able to see the kind of features that Predibase exposes as well from this data set. So I have the image path, which was the actual S3 location of this image of Santa, the label, and then the month. And for now, I'm just going to build an image classifier. So I'll actually disable the month and be able to go to the next page. And all I really need to do in order to get my first machine learning model is say, what is the target I want to predict? So in this case, I want to predict the label. Once I do this, I can click next, and you'll actually notice that train is immediately available as well. Now, one thing that I want to be able to point out is that this has essentially automatically configured this entire machine learning pipeline that I can see visualized here. I take in my images, I pre-process them, which is what's represented in this box. I pass them through a series of machine learning pipelines, in this case, a stacked set of convolutional neural networks that pass through a centralized combiner and come back with a binary output for a label out the other end. And I can actually, what I'll do is I'll go ahead and click train to start kicking off this job immediately. But one thing that I want to do right beforehand is just show you that this is kind of the default that you see. And this is the, the out-of-the-box machine learning model that Predibase has recommended for this particular task. But coming back to that spirit of the first model is usually not your last, one of the really powerful things about our platform is that you can actually customize any part of this pipeline that you want. For example, you can change the image pre-processing. So if you want to change the default height and width of the image, the number of channels that we use, how we resize them, if we use pixel normalization versus pixel standardization to scale them, you can essentially have control over all of these. You'll notice a key aspect about Predibase is that we give you defaults for everything, but every part of it is also configurable. So that's how we kind of support both the starting user that wants to just get started very easily and the expert user that wants full control. And one of the really powerful things about this is that you also get access to kind of a number of the kind of cutting edge state-of-the-art pre-trained models as well. So if I wanted to, for example, use a pre-trained model like VIT, which is a pre-trained vision encoder, I can use that and then fine-tune it directly on my data set as well. And that makes it so that I can get a lot more leverage out of maybe a smaller amount of label data that I might have in my platform. And so this ability to kind of control any aspect of the model development cycle, from the pipeline all the way through parameters in the trainer, like what learning rate and epochs and others I use, is what I think really makes the platform very compelling for having a high ceiling and something that also supports iteration quite well. So for the time being, what I'll do is I'll click train. And this will kick off model training, I think, on this particular instance. And then what I'll do is head over, because this will usually take, I would say, 10, 15 minutes. I'll go ahead and show you actually what a fully fleshed out repo can look like. So here's one that I trained just last night. And so in this model repository, you can see a series of machine learning models that I've actually trained in order to be able to predict whether or not there was Santa or not in an image. And you can see that I have this, kind of a description with all of them. And so here, if I just started to land and I wanted to get a sense of what did my model progression journey look like, I can click into the model lineage, and you can see I started with a basic defaults model, essentially the exact same one you just saw me kick off. And then I kicked off a series of different experiments to try and see if I could do better. So let's go ahead and click into, let's say, my basic defaults model and see how it did. So when I kick into an individual model version, you'll be able to see all the different metrics that you might care about. So you can see things like accuracy. So it seems like my basic defaults model got about a 92% accuracy on the test set. You can see loss curves, and you can also see, of course, the machine learning model pipeline that we initially kind of created for this. There's many other metrics that exist: confusion matrices, ROC plots, F1 if it's relevant. But I won't go through all of that just now. I think the key idea is you can actually get this view of kind of what an individual model version looks like, how long it took to be able to train, and then you can compare it to the different model versions that might exist in your repo as well. So you've seen here that I've trained many different types of model iterations. I've trained my basic defaults model. I've trained one with pixel standardization instead of pixel normalization. I trained a ResNet model as well. So I used something that had a pre-trained vision architecture. And then I added a final model where I essentially added calibration. And I can sort of go through these curves. Of course, this is way too many numbers, I think, for us to be able to dive directly into here. But if I just picked maybe my first model and my last and wanted to compare, let's say, instead of loss, the accuracy over these, I can kind of see that whereas my first model sort of peaked at, let's say, 92% accuracy in the 13th epoch of training, the final model, or model version 8, actually looks like it peaked at about 93.3% test accuracy and 99.6% training accuracy. And so my final model got about 1.3% better accuracy. And in some cases, that might be just a nice to have. And in some cases, that can be like a massive lift towards a business metric. So I think the key idea is you can continue to sort of iterate, as much as you might want to. If I wanted to, take a look and see what is the actual difference between model version number 1 and model version number 8, we have some really cool ways to be able to do that. So I can go into the model lineage, and then I can actually diff 2 models. So one of the really nice things about Predibase is that all of those, models that you saw are essentially just Ludwig configurations, which means that they can be summarized in just a little bit of YAML. So even though that machine learning pipeline was really complex, you can see that the code to generate it was just 9 lines in this case and about 13 lines in the final model version. And the difference between model version 1 and model version 2 was that I added some calibration, and then I decided to use an auto batch size. And so this led to about a 1.3% accuracy lift, and allows me to kind of easily see kind of these different types of models and understand, what the expected difference across them might be. So this is, what a fully fleshed out model repository could look like, and how we like to think about users essentially, thinking about our platform as they want to go ahead and iterate on those models. The biggest thing I wanted to go ahead and call out are really two things. The first is, one, I'm not a computer vision expert, but I was able to train a series of pretty advanced machine learning models without having to really actually, implement any of the internals. And I think that really comes back to the second piece of the value proposition that I wanted to point out, which was all of these things are kind of baked in for you, and you can essentially just select them from a dropdown. So if I want to use something like batch normalization, or I want to use a new model architecture like ResNet 50 or VIT, I never have to think about the implementation and making sure the size of the input tensors matches the size of the output tensors. I can just essentially select them, and then the system will figure out the best way to be able to optimize for it. Let's briefly check in to see how the other model's been doing, which I just kicked off here. And you can see a little bit of what it looks like, as it's actually in progress and training. So as it's training, you can see that we summarize essentially the amount of time that it took for each step in the machine learning modeling pipeline. So it was queued for about 40 seconds while it pulled up an engine. It spent about 2.5 minutes in pre-processing. And then now spending what I expect will probably be between 5 to 10 minutes in this training step before it goes to evaluation and others. One of the really cool things that I think you'll see, if we stay on this page for a little bit longer, is as those epochs actually come in, you'll see a live dashboard of updating loss curves as well. So you can actually kind of track your own model performance iteratively. One last thing I wanted to show you in the model building journey before we get to how we can actually operationalize these models is kind of what I was talking about earlier, which is how do we add additional metadata that might be relevant for this particular model. So, we briefly touched on how there might be other types of data like captions, or in this case, the month, that I might want to add in addition to the image. Now, usually for tabular data, it's very easy to add in an additional feature. All you do is add an additional column to your data set, and now your data, whatever tabular model you had to predict on your first K columns can now work on your K+1 columns. With images, it tends to be a lot harder. You need to update your internal architecture so that it can actually use this new tabular data as well as the 256 by 256 images that you had. With Predibase, though, it's just as easy as enabling the feature. So if I wanted to enable the month, I can just go ahead and activate it. And now if I actually were to go to my next page and see what it looked like, you could see that my machine learning pipeline now consists of an image path as well as the month. And that will go ahead and both feed into this centralized model that will come up with a label on the other end. And the really neat thing about this is that, in this case, the month is a categorical. It's just, January through December. But let's imagine it was something that was a little bit more like unstructured text and like something like the description of the image. I could then start to use, the text description and then encode it with its own machine learning pipeline. So something like a BERT or GPT-2 or DistilBERT, any of these kind of cutting edge text models. And I can essentially use the best of breed across these different representations to come up with a prediction on the other end. So just a very, today we'll stick with building just a simple image classifier. But I think one of the really powerful things about how we take this declarative approach is you can easily layer in additional features like as you might want. Maybe I'll briefly check this again to see, and you can see here the loss curves have started to update. So it's in training, and you can see, how it's doing generally. So at this point, it's kind of made it through its 7th epoch, and you just saw it update here as well. This is one way that you can essentially see and track, as model training happens, what's happening dynamically. And it actually becomes quite a fun thing for you to be able to kind of continuously look at and see exactly how those models are updating. Cool. Now, let's imagine we have that model that we're happy with. So this model will continue training for some amount, more time. But luckily, I have this model that, I think I'm pretty happy with. I've trained a series of 8 different models, which I could check in through my lineage. And I came with one that I'm, pretty satisfied on. And now I want to think about how do I operationalize this model? Well, there's a few different ways that you can think about that. The first is if you want to run this locally, you can essentially just export it out in the format that you think makes the most sense. So we support a number of different, export formats directly. If you want to deploy that model, you can deploy it to a REST endpoint in one click. And I haven't deployed this particular model, but I will show you kind of what that looks like as a user journey very briefly just through another example, which is when I click into a model version, I can click deploy, and I'll choose a deployment name as the really only required field. And then we will automatically suggest a serving engine, which you can override as the infrastructure on which that model will run inference from. And I can leave any comments that I might want as well. What this will essentially return is a REST endpoint that you can use to be able to ping this model from any downstream application. And then we have our kind of final and our favorite way about thinking about how we can actually deploy models for batch use cases in particular. And that's PQL. And PQL is kind of a unique interface that we have that essentially puts machine learning directly on top of your data. So if you saw that kind of initial SQL query I ran, where I selected 10 random users from the Santavision data set, one of the really compelling things about PQL is I can translate kind of this standard normal SQL query into a predictive query in just one line. So now what I'm going to say is, instead of selecting 10 random users from the Santa data set, predict the label. So use my machine learning model that I've trained in order to be able to predict the label on that data set. And what you'll actually see here is the model will use, this query will essentially ping that model live and be able to get the label predictions right next to it. So you'll be able to see, now I can scroll through my data set, and in many cases, the model might do well. And in some cases, the model might make some mistakes as well. So this is a really cool way for users to be able to essentially interact with their model directly on top of their data warehouse in a language that's really familiar to many users kind of these data systems. And one of the things that I think is particularly cool about it is that many users now can use your machine learning models without having to think about without having to think about Python code at all. So if you've developed a model but want to make it handy for any of your analysts kind of inside your organization, they can start to use it very easily in kind of this embedded way. PQL itself has many different extensions. So let's imagine you just wanted to, obviously this is just kind of a vanilla predict, but let's imagine I wanted to not only predict, but also get the probability of each prediction. I can do something called predict with confidence. And what this is going to give you is the prediction, but also how confident the model was in that prediction. And so here I can see, instances where the model was like much more certain, like 99, 100%. It was much more likely to get that prediction right. And then here where it was maybe more like 79% instead of very certain, it ended up getting it wrong. And so this is an easy way for you to be able to filter by, where the model is more or less interesting or confident. And then you can use that to be able to kind of fine tune where you want to make decisions. Maybe one last, thing that I'll go ahead and show you in terms of PQL, and I'll load this up just because this query might take a little bit longer to run, 54 seconds usually, is how you can do error analysis with PQL as well. So what I'm going to do here is I'm going to select, from the first 350 rows of this data set, where was the label different from the predicted label, and show me those. So here I only want to look at examples where the model got it wrong. And so you can kind of take a look at the types of Santa pictures that it got it wrong on. So this first one you can understand is actually pretty tricky. There's no red or Christmas colors really here. It was a Santa picture in the label, but the model got it wrong. And you can see some other cases where the model thought that this Merry Christmas, for example, model picture might have actually been a Christmas picture or a Santa picture, but the initial label was false. You can see this cat picture has some candles in the background that also feel pretty Christmassy, and the model thought that was true. This is just one way, essentially, for you to be able to introspect any of these kind of types of results. And I think the final thing to call out with PQL is once you're happy with your predictions and you want to be able to operationalize them, you can actually schedule queries to be able to run. So you can schedule queries to run every minute, hour, day. And what that will do is essentially pull from an upstream data source, run your predictive pipelines, and then write back down out to a downstream data source as well. And so an entire way for you to have your batch machine learning pipeline set up in one. So that's a little bit of what I wanted to show you today around being able to do kind of a very simple image classification task with a holiday twist to it using Predibase and declarative machine learning. And what I will do is recognize that I've spent a large part of the last 45 minutes just talking, and would love to now be able to hear from you and maybe answer any questions that you all might have.
Awesome. So why don't we move to the Q&A, Deb, and I'll just start going through some of the questions that came in and through the session. So first one for you, excuse me, how would you compare declarative machine learning approaches or Predibase to AutoML tools? like Data Robot, Domino, and the like?
Definitely. Yeah. So I think where AutoML tools really excel is they have a high degree of simplicity today. And it makes it really easy for you to be able to get to a first model. I think with Predibase, like our thesis is that a first model is usually not your last. So we view AutoML as your starting point. So for example, if I click into my repository, this basic defaults model is very similar to AutoML. In fact, it is our AutoML suggested first model. It's the pipeline that we've set up with all the kind of configurations by default. But in particular with deep learning, there's a large number of parameters to be able to explore. And some of those kind of model architectures are too heavy to explore with like a broad sweep AutoML approach. And it really requires a little bit more of a data science scalpel. And so that's where kind of these next series of iterations came through up to my final one. And each of these was just tweaking some individual configuration parameter very easily. And so the way that I would think about automated machine learning is a really good way to get to your first model. But at least with a lot of the customers that we've worked with, oftentimes they see kind of a dead end with AutoML, and we want to make it so that there is no dead end. You know, that this experience feels a little bit more like a co-pilot where AutoML is just the suggestion for your first model versus an autopilot where it's kind of just running everything for you and you don't have any ability to make further progress.
Awesome. Thanks, Deb. Another question was about sort of Predibase or Ludwig support for generative models. Can you speak to that at all?
Definitely. So, you know, I think that's a really good question in particular where generative models have been really popular today. I think the actual interesting thing to look at might be here. So this model architecture does actually support your ability to generate unstructured output as predictions. For example, if you had an image as an encoder and text as an output, you would have an image captioning system. And this is essentially going to generate the text to be able to caption a particular image. Now, you could also imagine you could have, you know, for example, to do something closer to what GPT-3 does, you could have text as input and you're trying to predict other text as output. And so if you wanted to use, for example, if you wanted to build your own generative model, I think doing so with Predibase would be just a matter of making sure that you had the data to be able to predict, making sure you had the data to be able to build that model, and then being able to set that output to be the type of data that you want to generate. So that could be a text, it could be an image, it could be other types of things that you want to generate. And you can actually try this directly in Ludwig today. I think, you know, if you were to look at the ludwig.ai docs, I can just point you to a very brief tutorial around, I think, what example use cases. And I think, yeah, dialogue modeling, for example, I think is a good example of like where you have input text and you're trying to predict some output text as well. So that's one way to think about generative models in the context of Ludwig and Predibase. And then the last thing I think I'll briefly mention is that actually we also support a number of different types of architectures you might care about for large language models. So here I'm going to switch to a text model for a second because I think it's easier to show some of the generative capabilities. But if I were to click into you know, the actual model pipeline, you can actually see that, you know, BERT, for example, is like a large language model I can use directly, but I can also support other architectures like GPT-2 and essentially fine tune them to my data set using Ludwig directly.
Awesome. A question just came in actually about on the deployment side. So yeah, can Predibase automate model deployment after training? Obviously, it takes a long time, even after training, let's say, to get a neural network to deploy into production, since you need to recode it for your app, which might not be in Python. So can you speak a little bit more to that?
Yes, great question. So the answer here is yes, that's newer functionality that we've actually just developed and released. And so let me see if I can pull up like a brief example. So the way that we think about doing deployment is you have a model that you're initially happy with, and you want to deploy it to a REST endpoint. So here I'll choose a deployment name. And so I'll say something like, this is my first deployment, and then a serving engine. Now, you don't have to select a serving engine because like most things in the platform will provide you with a reasonable default. But if you wanted to deploy to a specific type of infrastructure, we give you that flexibility. Once you deploy that model, you'll actually see something very similar to this. This is a very, very simple you know, initial implementation here. But we kind of give you this REST endpoint. that you can then use and start to ping from any different like application that you might have downstream. And so this REST endpoint is one that you can start to use from, let's say, your backend service or a downstream client application, and you'll essentially just feed it a payload, like a JSON payload, that you can start to get predictions from in real time. And we've done a lot of work over the last 2 quarters to make sure our deployment story is really high throughput and low latency. We're going to be adding more functionality in the coming quarters around MLOps and observability for some of these parts of functionality. But right now, if you wanted to serve a model kind of right out of the bat that you developed, inside Predibase, you can.
Awesome. And Deb, there's always interest in sort of PQL. So I want to ask, how does that work with like a Snowflake as an example?
Yeah, that's a fantastic question. And one that I hope that we'll be able to maybe publish something around that will give you a better understanding too. But maybe the very brief look at it will be, if I look at a PQL query like this today, I can select the connection where my data set is. So in this case, my data set was just a file. But if instead, I had data in this case, BigQuery or something like Snowflake, I can start to query those data sets with my models directly without having to move the data into Predibase. So what will specifically happen is that, anytime I select data, we'll push that data selection down to Snowflake. So it'll run directly in your cluster. And then we'll just augment it with something like the predict statement on top. So we support Snowflake as a data connection today. In order to connect Snowflake, it's a very simple series of just credentials that you would go ahead and pass on and what database you want it to connect to. And once you've connected Snowflake directly, you can start to run your predictive queries directly on top of it. And one brief note I want to make about PQL is I mostly just showed it in the context of being able to do some predictions, but PQL is actually a very expressive language already. So if you wanted to even create models using PQL, that's actually something that's supported as well. So you could take your data from Snowflake and then use PQL to be able to create models directly on top of it without ever having to leave this kind of SQL-like interface.
Great. Another question. What are some of the other common use cases that customers of like Predibase or users of Ludwig typically implement, some of those patterns you see?
Definitely. So I think that what we typically see is customers are usually in kind of one of 2 types of buckets. The first is, hey, I can build my tabular models just fine. Like I'm familiar with a linear regression or a logistic regression or my tree models. But I'm having difficulty with the infrastructure, which might be scaling it up to larger workloads or deploying it. That's one type of customer. The second type of customer, which I'd say is probably the most frequent for us actually, is I know how tabular data models work. I can train my XGBoost, but deep learning is much harder. And so I have unstructured data that I want to be able to take advantage of that I'm really struggling to be able to build kind of my conventional pipelines with. And so these types of use cases that we really like usually involve things like text, images, and maybe even other unstructured modalities as inputs. And so the kinds of use cases that might come up are, for example, building content classification systems. So, if you're trying to classify email or incoming messages from your customers based on historical taxonomies that you might have had. This image classifier is, something that we've seen from an external user that was trying to do something for defect detection. And then we also really like to see, things that combine different modalities, so maybe text and images. And we've recently seen more folks that have been interested in recommender systems, in particular for digital content there. And so those are kind of a few different flavors of the types of series that we see. I would say Predibase and kind of Ludwig is really helpful for those that want to massively simplify building deep learning problems. And so any areas where deep learning or use cases where deep learning is particularly effective usually tends to be something where we can add a lot of value. And so anything that involves text, images, unstructured data, or really large data sets, I think tend to be much easier to do in our platform than try to build separately.
Great. I think we have time for maybe 1 or 2 more questions. Another one that came in is, you touched on some of the new capabilities that Predibase is building. What are some of the other things on the roadmap, and maybe all the other sort of key things that people really like in the platform or within Ludwig that you weren't able to share today?
Definitely. So I won't have an opportunity in the final 2 minutes to talk about all of the things that are coming in our roadmap, because the team is really working on quite a few different aspects to try and make this platform more valuable. But maybe I'll touch on 2 to 3 aspects that I think I'm particularly excited about going forward. The first is, the deployment, kind of showing up that deployment story in a lot more kind of like robust way. So right now we have that ability to deploy to, this REST endpoint, and you can start to see it and ping it. And you can write some queries to be able to know if things like have drifted or not. And I really am excited for us to be able to build a more holistic story around the kind of monitoring and observability around it. And that's one part of the MLOps story. The second part that I think a lot of our users are going to like is we've noticed that, users can build their first model really easily, but then afterwards, there's some expertise that might still be required in order to know, how do I want to iterate? Now, data science is both kind of an art and a science. So some parts of it is, you just need to try out a lot of different things, and the platform makes it very easy to experiment. But one of the things that we've noticed is that when we work with customers, we pretty consistently have like a series of suggestions that we like to make. And we kind of tell customers this verbally. And what we're actually going to do in the next quarter is bake these suggestions back into the platform. So the idea is, after you train your first model, you could actually ask the platform, hey, what would you suggest I do next? And the platform would have an answer for you. And that's an area that I'm actually really excited about our upcoming investments in.
Oops, there we go. We're at the top of the hour, so if we didn't get to all the questions, we'll make sure we follow up via email. But I want to thank, first of all, Deb, for the great presentation today, and thank you everyone for attending. As a reminder, the session's recorded and we'll share on YouTube, so you can watch portions later, or share it with your peers. And if you're interested in trying Predibase or Ludwig, you can visit predibase.com or ludwig.ai, and we'd love to have you in the community. So thanks again, everyone, and have a happy holidays.